Okay, so this is my code for project one. I use pandas and NumPy, and then I coded everything in Jupyter Notebook. So let me start from the top, and I have four different sections. So one is pre-processing, which is importing the data, and then applying some rules to clean up the data regarding the missing values and multi-category values and continuous value. And then number two is implementing the algorithm with Node2 and Naive. Number three is evaluating the data set using the algorithm I implemented. So this is applied for each data set, all five of them actually. And step four is running the experiment repeatedly with 10 times iteration so that we can get more stable number. So let me start from the top and then show you the running code. So import the library and then import 5 different data set. And then it's applying discretization and the one hot encoding. And then the steps are discussed in more details in the report. And the second part is algorithm. So basically, it mainly has like the trainer and the predictor. So you can train the Wino2 model and then predict the output based on the trained model. And then this is helper function for printing the trained model. And Naive have the same three functions: training, predicting, and training the model. So I register all these functions. Let me try to run this function against the data set, and then show this running. And then there are more helper methods to evaluate the data set and then get the performance metrics. So let me run step by step on one of the data set, breast cancer, so verbose version. So step one is firstly shuffling and dividing the data set. And then step two is training the Wino2 model. So you can see the model output actually. So these are the hot one encoded feature. And then what's on the right are the weights that are gathered or trained, derived by the training method. And you can evaluate the Wino2 model against the testing data set. So the left column is predicted values, and actual values are coming from the testing data set directly. And then we can get more metrics on accuracy, precision, recall, and F1. And Naive has similar steps. So train the model, evaluate the model. So note that Naive actually has bigger model because it is posterior probability for feature attribute and class attribute, every combination of it. So it has more rows and columns, and then the output looks similar, predicted and actual. And then it also has the more metrics. And for the sake of time and length of this notebook, I combine everything into one and run the experiment for all the other data set as well. We should note that since those are multi-class data set, I actually have to build classifier per class, and then metrics are gathered per class. And I also computed average across all the classes. Say rando 3 data set, and then the last step is running the experiment repeatedly with some iterations so that we can get more stable number. And then there are two versions of it, one on binary data set, the other on multi-class data set. Right? So for vote and breast cancer, let me just run them all so that we can save some time. Oops. Yep, so it's running. So it's currently running on breast cancer data set, I think. Let's give it a little more time. So it's giving the average over 10 iteration for all these metrics. The multi-class one, of course, takes longer time because each model, each data set has more classifiers, right? So you can see the average per class and also across all classes. The same thing is running for soybean and class dataset. Will come shortly. Great, there we go. The last one. Okay, so that's it.